Hey everybody, this is Alex Merced, and welcome to another episode of Gnarly Data Waves. Here in episode 36, we'll be talking about how to simplify your Lakehouse operations with zero copy clones and multi-table transactions. But before we go there, what I want to do is make sure to invite you to get your hands on with Dremio, and there are many ways to try out many of the features with Dremio. Okay, there's many self-managed ways where you can go use Docker, Azure, AWS, Google Cloud Platform, Kubernetes, Yarn, or use a standalone install on Linux. Any of those ways, well, work. Okay, that's if you want to get started with Dremio software for free. If you want to get started with Dremiocloud, you can just create a free account in moments using single sign-on with like your Google account, your Microsoft account, your GitHub account. But if you want to try out Dremio Cloud before you do that, you can go over to Test Drive where you can get hands-on and get a feel for the Dremio Cloud platform before you actually create a Dremio Cloud account. Also, there's a new blog over there, dremio.com/blog, where I actually walk you through the steps of spinning up a Dremio Docker container on your laptop and just trying out many of Dremio's features. It's a great way to get started with Iceberg and with Dremio all in one blog. So go check that out at dremio.com/blog. Okay. Also, basically, there's always been Apache Iceberg, the Definitive Guide, the book that me, Dipankar Mazumdar, Jason Hughes, and Tomer Sharan are all working on to be released early next year by O'Reilly. And me and Dipankar, we're going to be over there at Data Day, Texas, doing an Iceberg AMA. Okay, if you want to get an early copy of the book, you can go scan that QR code right there. Also, come down Data Day, Texas in January to come join us for that event. Now, speaking of events, Dremio's going to be at several events in the coming weeks, including Coalesce 2023 with DBT over there in San Diego, October 16th through 19th. We're going to be doing a Data Lakehouse meetup in London on October 17th. We'll be at AWS re:Event on November 27th in Vegas. And we're going to be at the Microsoft Azure and AI conference December 5th through 7th in Orlando, Florida, in my stomping grounds. So make sure to stop by the Dremio booth at any of these events and pick up some cool swag and learn a little bit more about the lake house. And as you see, Dremio, we've been putting out a lot of great content to help you with your data lakehouse world with all these kind of new articles at the Dremio blog, which you can go find at dremio.com/blog, including articles on how to set up Dremio on your laptop with Iceberg and Nessie, a deep dive into the architectures of Iceberg, Delta, and Hoodie, learning how to use Airbyte to ingest data into Iceberg, and so many other great articles walking you through how to do things with your data lakehouse and how to optimize things and new features. Go check out dremio.com/blog. Lots of great content. And of course, there's also the weekly show we have here at Gnarly Data Waves with so many great episodes on the way, including next week where we're going to have NetApp come on and talk about how they were able to kind of improve their customer experience with product analytics used through the adoption of Dremio. And then following that, we'll have Jacopo Tagliabue, founder of Biopen Labs, talking about how he's building a data science platform using Apache Iceberg and Nessie. And then after that, we're going to have a session on how to build an Iceberg data lakehouse with Fivetran and Dremio. So make sure you just keep coming in every week. And with no further ado, we're going to get to our featured presentation. And with episode 36, how to simplify lakehouse operations with zero copy clones and multi-table transactions with our guest, Jeremiah Morrow, product marketing director for Iceberg and Dremio Arctic here at Dremio. Jeremiah, this stage is yours.
Hi, everyone. My name is Jeremiah, and I'm responsible for product marketing for Iceberg and Dremio Arctic. And today I'm going to be talking about simplifying lakehouse operations with zero copy clones and multi-table transactions. Here's a quick agenda for this session. First, I'm going to level set by talking about the journey from data lakes to data lake houses. Then I'm going to do a quick review of what Dremio Arctic is. I'll talk about gitfordata and how you can create a zero copy clone of your production data in just a few seconds. Then I'm going to walk through a use case of gitfordata, which is multi-table transactions. And finally, I'm going to do a quick demonstration of how that works in Dremio Cloud. Then we'll do Q&A. You don't have to wait until the end to submit your questions. Feel free to drop them in the Q&A tab at any time. So first, let's start by recapping approximately 40 years of data architecture history in 2 minutes. We're going to start a long time ago with data warehouses, and data warehouses were great at what they were initially designed to do, which is storing and analyzing structured data from business systems in the data center, and they could deliver BI and reporting on that data in a reasonable amount of time. But the EDW couldn't really keep up with the growth of data volumes or the variety of data and data sources. And so companies turned to the data lake. The data lake was also really great at what it was initially built to do. It was really great as cheap and efficient storage for all of your data and for exploratory data science projects, but it never replaced BI and reporting capabilities of the EDW. And so what we have in probably 99% of companies we talk to today is this cooperative architecture with a bunch of data lakes and a bunch of data warehouses doing basically what they've always done. You do BI and reporting in the data warehouse, and you do data science in the data lake. And the challenge with this architecture is that more and more of our operational and customer data is going to land first in the data lake. And so our BI and reporting users need access to that data. And so when they do, we have to move it into the data warehouse. And data teams get a ton of data access requests. And those ETL and ELT processes become a bottleneck where it can take weeks, days, months in order to get access to an important data source for your report. So Dremio has been fantastic as a tool for doing two things. First, enabling instant data access to data in the data lake and any other data source, so data consumers can get to the data they need faster. And it also provides super fast query performance on that data, so data consumers can get answers to the questions that they're asking their data much more quickly. And in fact, we've had query engines on data lake storage, and this has sort of been the way to access data lake storage for quite some time now. But to move from a data lake, which is primarily for read-only queries, to a data lakehouse, which combines the flexibility and scalability of data lake storage with the full read and write functionality of the data warehouse, we need a few more components to effectively and efficiently manage that data. So you're not going to find too many companies today arguing against the value of file formats like Apache Parquet from a compression and performance standpoint. And so the next layer on top of that that companies are looking into now is table formats. Table formats like Apache Iceberg build on that compression and performance capability of file formats and bring a lot of the missing elements of a data warehouse to the data lake, including ACID transactions, versioning, and time travel, and table and schema evolution, all of which enable the data team to transition more of those data warehouse workloads into the data lakehouse. And the final piece of the Lakehouse stack is a catalog that makes it easier than ever to manage your Lakehouse. And for that, for us, that's Dremio Arctic. So Dremio Arctic is a lakehouse management service. It sits on top of your data lake, and it provides data optimization by automating a lot of the capabilities of Iceberg. It provides governance and security, which is really sort of table stakes for a data management solution today. And it gives data teams the ability to use this concept called gitfordata, which is Git-inspired versioning for your data lake that makes it really easy to deliver a consistent and accurate view of your data to all of your data consumers. And we'll go through a few of these aspects piece by piece. So Dremio Arctic is a modern lakehouse catalog. As I mentioned, it's Iceberg native, so it's based on Project Nessie. So it's tightly coupled with Apache Iceberg, and a lot of Arctic's capabilities are based on the Iceberg architecture. Very importantly, it's also accessible by multiple engines. So we firmly believe that the future is multi-engine, and data teams are going to choose the best tool for each workload. So we're committed to ensuring that our customers have that flexibility. And from an access control standpoint, obviously none of this data management solution works without security and governance. And so Dremio Arctic features fine-grained access controls and integration with existing user and group directories. From an automatic optimization standpoint, Arctic takes some of the capabilities of Iceberg from a data management perspective and automates them. The first is compaction. So compaction rewrites smaller files into larger files on a set schedule to improve read performance. That's great for use cases that require streaming data or micro batching data into the data lake where you're bringing lots of small files in. And today that's a manual task for a lot of data lake owners. The second piece of this is the vacuum function or garbage collection, as it's sometimes called. And vacuum removes unused files on a set schedule to conserve storage space. So automatic optimization is all about automatically improving performance and also storage utilization. My favorite feature of Arctic is Git4data. So the idea is this: GitHub transformed the way developers build and deliver software code. Branches, tags, and commits introduced things like CI/CD, version control, governance, and quality insurance, while also improving collaboration and accelerating delivery. And now with Git4data, you can do essentially the exact same thing with data products. So in this graphic, I have my main branch of data, and that's the source of truth for my organization. All my data consumers hit that branch for their reports and their dashboards. And so I want to make sure that view is consistent and accurate. If I want to make any changes to the data, I'd create a branch, which uses metadata pointers to create a view of the catalog at a specific point in time. So it's a clone. It's not actually a physical copy of the data. And so within that branch, I can really do whatever I want. In this graphic, I have a data science branch at the bottom. So my data scientists can experiment. They can run scenario analyses. Really, they can do whatever they want with a clone of the production quality data and without impacting production users. And then my top branch is an ETL branch. This way I can bring data into the branch. I can do my transformations. I can check it for quality. I can even run a dashboard against the branch data to make sure that I didn't break anything. And then I can merge it into the main branch. And only after I'm confident that it is a high quality view of the data that has the changes that I was intending to make, will my production users be exposed to those changes. So these are a few of the benefits of managing your data with Git4data. The first, obviously, is isolation. All of the work done on a branch happens without impacting other branches and other users. So my production view is safe and none of those other users are impacted. The second is version control. I can very easily reproduce a view of the data at a specific point in time. And if a mistake does happen, all it takes to roll back that mistake is to change the main branch header to a previous commit. And I can, in fact, roll back an entire catalog in just a matter of seconds. And finally, from a governance perspective, all of these changes are tracked and audited. You have a full history of what happens within a branch. And we have access controls to make sure that the right people can access data and make changes to that data. So let's go through a common use case for zero copy clones and tackle something that is traditionally a challenge within data management, especially in the data lake space, and that's multi-table transactions. So in this graphic, I have three tables, and I might have a data consumer who has a virtual data set, which is a join between these three tables. They might even have a dashboard that visualizes that virtual data set. So I might need to make an update to more than one of these tables at a time, but I don't want that data consumer to see a partial or incomplete view of the data. That is a view of the data before all of those changes are made. So the solution with Dremio Arctic and Git4data is to do all of those updates in a separate branch. So I can create a test branch and then I can make changes and updates to the tables. I can do a quality check, make sure I'm happy with those changes, and then I can merge to main. The changes are made atomically on the merge. So any of my production users who are accessing that joined virtual data set that I mentioned before won't see any of those changes until all of them are made on the merge. So every data consumer essentially has access to a consistent and accurate view of the data. So now that I've talked through this graphic, I'm actually going to jump into Dremiocloud and walk through these steps so you can see how it works. Okay, so here I am in Dremiocloud, and Dremiocloud is two services today. The first is Dremio Sonar, which is our Arrow-based distributed SQL query engine, and also our unified access layer. And then we have Dremio Arctic, which is our data lakehouse management service with gitfordata. I can do some of this work in either. Within Arctic, you can do a lot of this stuff in a low code, no code sort of way. But because I want to run some queries, I'm actually going to hop into Sonar for this project. So here on the Dremio Sonar home screen, you can see I have my data sources off to the left, including two Arctic catalogs. For this project, I'm going to choose Dremiotest. And now I have a couple of folders. So let's hop into agents and customers. So within this folder, I have three iceberg tables with roughly 1,000 rows apiece. Customers, agents, and jobs. And then over here, if I click on my email address, you can see I have a virtual data set here. This is jobs joined, and this is a virtual data set, which is a join between agents, customers, and jobs. So let's say one of my agents onboarded a new customer, and so I need to update the customer table and also the jobs table. But I want anyone who's using the jobs joined view that I showed to see the updated tables only after I've made updates to both of the tables. So to do that, I'm going to create a branch of the main Arctic catalog. So I'm going to hop into my SQL runner here. And we're going to simply do a create branch command. There we go. So I have created a branch. And so if I click on this, you can see I have my new branch here in addition to the main branch, and it is a clone, as you can tell from the commit history here. So I like to change the context here to make sure that I am actually updating just that. And so now I'm going to update the customer table. I'm going to add our new customer. So I will do an insert statement and add Jeremiah Morrow here and an email address. Cool. So now my customers branch has been updated, and now I need to update my job table as well. So I'm going to add this job row here. And go ahead and run. Cool. And so now I've updated both tables. I'm going to check account here. And I'm going to select account from the jobs table on the branch. And so my original table had 1,000 rows. This should have 1,001. And as you can see right here, it has been updated. We do have 1,001 rows. Cool. And very importantly, for this whole project, obviously I've been updating the jobs table update branch. Let's run a select count on the main branch here of the same table, so the jobs table. So we should still be at 1,000 rows, and we are. So my production users have not seen any of the changes that we've made so far to these two tables. And so updating the main branch is as easy as just doing this merge branch command. So we're going to merge the jobs table update branch into the main branch, and this will make atomic changes to both tables. And so now my production users should see the updated tables. And very quickly, we will go ahead and do a select count of the main branch jobs table, and that should now be at 1001. And it is, so you can see that we have made the changes. And so just to show how easy it is to roll back, say I didn't want to make that change after all, or I did something incorrectly, I broke someone's dashboard. The good news is rolling back is super easy. All we have to do is assign the branch header to the commit prior to that merge, and we'll undo the changes that we just made. So that looks like this with the alter branch command targeting main. And so now we just need to grab the commit ID. So we'll go back here to the main branch, and you can see you have your entire commit history right here. So this was the merge, and this is the where we want to travel back before. So we'll go to the previous commit, we'll copy this commit ID, and then we will insert it here. And there we go. We've now rolled back the entire catalog to the time before the commit. And just to show that our main branch has been rolled back, we should be back at 1000 rows here prior to the customer, and we are at 1000. So there we go. To recap, we had an Arctic catalog with 3 iceberg tables. We had a join within our production environment that depends on those 3 tables. So if business conditions require us to make updates to multiple tables and we don't want to expose those changes to our end users until all of those tables have been updated, we can create a branch, we can make our updates, check our work, and then merge the main branch with the or the test branch with the main branch, and all of those changes are made atomically. And then we can roll back those changes in just a matter of seconds with an alter branch statement. So that's in a nutshell how Dremio Arctic and Gitfordata make multi-table transactions very easy and seamless. Again, if you want to try Dremio Arctic, it's now the default catalog within Dremiocloud. So all you have to do is create a free account and start testing it today. And we'll include a blog post in our follow-up to this that shows you this exact project so you can try it out for yourself. So again, my name is Jeremiah. Thank you very much for joining. And now we're happy to take any questions you may have.
Hey everybody, it's me again. Now we're going to be doing Q&A. So if you have any questions, please send them over into either the Q&A box or the chat box. I will be monitoring those for any questions that you may have on Jeremiah's great presentation today. And let me just make sure I got everything nice and open. Good. And and yeah, I mean, I guess first off is like, is it now when I create a branch on Arctic, are you really telling me that basically any queries that are coming in from my day-to-day data consumers, my data analysts, my data scientists, who are depending on sort of like consistent information, they're not being exposed to what's being on that branch, assuming that all queries are going to go straight to
Yep.
the main branch?
Yep, that's correct. That is the value of Gitfordata. Make sure that your users have a consistent, accurate view of data at all times, and you can do anything you want in that branch on production level data, and you're safe.
Cool. Oh, here we go. Before committing into the main branch, is there a feature of manual review of the changes?
So you can definitely do review checks. I showed that in the demo by checking the count of rows within the branch to make sure that the updates have been made. You can certainly, in the case we do this sometimes with ETL pipelines, for example, where you can actually run a dashboard against your branch. and see that the changes have made, that the data has been updated and all of that prior to making the merge. So those are ways to check for quality. And I've seen some people automate that quality check with scripts, and I've seen some people do it manually. I think that's
Yep. And then so just as Jeremiah just said, you can manually see the state of the data on the branch. So in that case, if you wanted to do like a manual review before merging, like let's say you're the person doing the changes, but boss is supposed to do the review, they can just do the review once you're done with your checks. There's no like flag for a manual review at the moment. Cool. Any other questions?
yeah.
Oh,
I'll add to that also, from a review standpoint. I showed it sort of in the commit history when I was rolling back, but if you want to check the state that you're rolling back a branch to, you can actually reference that snapshot, and then you can run the exact same sort of quality check. Okay, hey, I'm rolling back to the state of data that I want to see. Before you actually make that rollback. So that's a pretty cool feature. All of those snapshots are available for you to check out.
yes, no, that's super powerful. Another thing to keep in mind is like again, Dremio's has role-based access controls. So in that case, like not every user is going to be able to just create branches and roll back the catalog. You have control over which users can. So basically, your data engineering who are handling the ingestion ETL, they can have the permissions to do that, and then everybody else, they're just querying that main branch. And they don't need to be any wiser and don't have to have the ability to accidentally like roll everything back. So you can
Yeah,
have those
and
controls.
same for merging a branch into the main branch. That is a roadmap item that's coming very soon, is the ability to manage permissions on who can actually merge to main. That way you don't have a data scientist just merging their science experiment into your production branch. So yeah.
Yes. So yeah, so you got really robust controls. But yeah, with that, any other questions? I'll give it one more moment for any additional questions before we call it a day. Let's see here. These two questions have been answered, so I mark those.
Alex, one thing I hear, I was at a data science conference last week, and there was a lot of confusion around the idea of the clone. It's not a copy of the data. You're not storing that anywhere. Can you talk a little bit about clone versus copy, I guess?
Yeah. So basically, what happens is that in a traditional environment, like what would happen is that like let's say you have your data scientist and they want to have a copy. They want to have the data so that way they can make make X and Y change the data, update these rows, see what happens to the model, whatnot. Problem is, if they mutate that data then doesn't become as useful for analytical use cases because it's been sort of tainted with experimental data. So usually what would happen is you would make literally a full-on copy of the data in a separate folder or in a separate environment that those scientists. So then you've just duplicated your storage costs. Like in Git, when you create a branch, you're not creating a physical copy of your code. You're just creating a different. Essentially, all Git or Nessie is doing is they're tracking a series of changes. So essentially, when you create that branch, all you're doing is you're tracking all the changes that occur on that branch separately than the changes that occur in the main branch. So you're essentially working from the same data, but the changes are which changes are visible depending on which branch you are different. So you're not creating a duplicate. The only new storage is any like inserts, any files created from new transactions, which are again are only going to be the new records or delete files to track deleted records. So essentially, your storage costs don't explode because you're creating all these copies, and that's a great thing about like using Arctic or Nessie. Literally, you just create a branch and you essentially theoretically have a workable copy of the data that someone can use for all sorts of experimentation without actually literally making a copy.
Yeah, that's super useful when you think about your production environment. Some people have dev test copies for their data, a completely separate environment, completely separate storage and compute and all of that, and then data science. And then, yeah, you could be managing multiple copies of the same exact data. So
Agreed. That's the
yeah.
great. That's a great thing about like zero copy clones because there's no copy, but you have
Yep.
another copy.
Yep.
Yeah, it's like Dr. Jekyll and Mr. Hyde. There's two people, but one body.
Yeah.
um, with that, I think we're gonna wrap this up if there's no more questions. But with that, Jeremiah, always delightful to have you on, and we'll have you again on very soon in the coming months. And then next week, make sure everyone comes in next week. Next week, we're going to be having NetApp come in to talk about how they use Dremio to really like reduce costs and really improve some of the projects that they were working on. There's some really exciting customer stories. If you haven't gone to dremio.com/customers to hear about how like OTP Bank saved 60% on their data storage, or how AP Integral was able to take a project that was going to take them 3 years and get it done in a month thanks to Dremio, go read those stories. They're actually really exciting and really kind of get you excited about the possibilities of what happens when you sit there and see of data lakehouse architecture in general, but also how Dremio can fit into that architecture. So hopefully you guys signed up for a free architectural Dremio, a free architectural workshop with Dremio, so that we can see, hey, where you're at, where you want to be, and what advice we can give you in getting to where you want to be. And again, it's about getting you where you want to be. And then we either fit in that store or we don't, but we're going to help you get there. So we'll see you all next week. Have a great day and enjoy.
Bye, everyone.